Okay, versus the one on the right. Does it ever stop? At t equals 3 and 5 seconds. When is the particle moving left or right? Or is the particle moving left or right at t equals 4 seconds? Remember, left and right means is it above the x-axis or below the x-axis? So on the first one, is it going left or right? It's going right because it's positive. T equals 4 right here. Is that one going left or right? Left. Okay, now this next part is going to be interesting. Let's see. Do this. Oops. Oh, where'd it go? There it is. Okay, I'm trying to do 2 screens here. I know I can go left and right, but I need to be able to see top and bottom, so we can still see the graph. Alrighty. Evaluate this one. Ooh, not so great on the quiz. Evaluate v of 0. That doesn't mean when is the graph touching the x-axis. That means plug in 0. Where is it at 0? It's at 0. Both of them are. Okay, part E, what is the particle moving left for the one on the left? What? Never, because does it ever dip below the x-axis? No, it doesn't. Never. Okay, versus the one on the right, when is the particle moving left? 3 to 5. So there's 2 ways you can write this, 3, 5, or 3 is less than t, which is less than 5. I would not put equals because at 3 and at 5 it's changing from going left to right. If it was an endpoint, you can put equals. But if it's in the middle, you don't put equals. Is the particle speeding or slowing down? Okay, speeding, double E, meaning, so it has to be the same. You know what speeding? If acceleration and velocity are the same sign. So what I'm going to write right now is just notes. We're speeding when velocity and acceleration have the same sign. EE, 2 same vowels in a row, EE. Velocity, acceleration, the same sign. Versus slowing, velocity and acceleration have what type of signs? Different signs. So, at 3.5, look at the graph. You should go through and mark acceleration and velocity signs. This entire graph is velocity negative or positive? Positive. So all sections we have positive V, positive V, positive V, positive V. At the beginning, what's the acceleration? It's increasing, this positive slope, so acceleration is positive. What's acceleration here? 0. Okay. What's the acceleration here? Positive, because it's not writing. Increasing. What's acceleration here? Because it's going down. Okay, so we're looking for, when is it speed? That's 3.5. What's going on? 3.5 is right here. We have the same signs. So is it speeding or slowing? The velocity and acceleration are the same. Speeding. So you should go through and mark your graph so you can determine if it's speeding or slowing. On the next one, Is velocity always positive? No. Positive, 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 and now it's negative, negative, and then positive again. And the acceleration, what's the acceleration from here to here? Good, because it's increasing, right? Amisha, what's about there to there? 0. Okay, Joanna, there to there. Negative. So in both of these sections, we'd write negative, right? Okay, and from here to here, someone over here, how about read? Positive, both sections. So if we want to know when it's slowing, oh, we didn't do that one yet. At 3.5, 3.5 is right here. It's speeding because they're the same. G, when is the particle slowing down? We know it's slowing when acceleration and velocity are different signs. So go through, if you've marked it up already on the last problem, then it should be easy. Tell me when I get to a different section. Yeah, the very last one. When is the particle slowing down from 5 to 6? So two different ways you can write that. 5 comma 6, parentheses, or 5 less than t, which is less than 6. But is 6 an endpoint? Yeah. So I should probably actually put a bracket and an equal. Yeah. It's not changing, yeah. Okay, this one, when are we slowing down? We're looking for different signs. So when do we see that we have different signs? 2 to 3. Union, I think there's another one, right? 4 to 5. Okay. Or you can write where's the particle moving the fastest? Speed on the velocity function, you know it's stopped when the velocity function is on the x-axis. So how do you know when it's going the fastest? The furthest away it is, which we take the absolute value, so it doesn't matter if it's on the positive side or the negative side. So on H, when's it going the fastest? Meaning, when is it the furthest away from the x-axis? Yeah, t equals 5 seconds. Okay, the other one, when is it the furthest away from, when is the particle moving the fastest because it's the furthest away? I think, yeah, we have a little bit of a tie, right? 0.5 to 2, and at t equals 4. Because absolute value, they're both 3 units away. And the last one, determine if the following statement is true or false. A of 3 meaning acceleration does not exist. At 3, here, does the acceleration exist there? How do we know? What are we looking for? Acceleration, isn't that the derivative? So it has to be differentiable. If it's differentiable, then the limit as x approaches some value of the derivative from the right has to be equal to the limit as x approaches that same value from the left of the derivative. So looking at the slopes, from the right, my slope is like 0. That's my left. The left, the slope is 0. From the right, the slope is 1. Are those the same? No, they're not the same. So, true or false? A of 3 does not exist. True. True. A of 3 does not exist, but you have to justify it. I need a little more room to write. And you can justify it by talking about limits. You're going to say the limit as x approaches 3 from the left of the acceleration does not equal the limit as x approaches 3 from the right of the acceleration. I should think we should put a t in there. Because 0 doesn't equal 1. Okay, what about this guy? At f equals v of 3, does that exist? Look at the slope coming into that. What's the slope? It's negative 3. Down, rise over run, negative 3. What's the slope to this one? I know it's going to the right, but it's still negative. Negative 3. Are those the same? So, true or false, a of 3 does not exist. False. And you have to, a of 3, we say, does exist. And we can prove that because the limit as we approach 3 from the left of a of t equals the limit as x approaches 3 from the right of a of t, because I think we said it was 3 equals 3. Okay, so if that quiz is holding you back, I think this is very important. I have made a new version of the quiz. I will allow you to retake it, but you've got to be studying this paper and get an excellent grade. You have to know what's going on with acceleration, velocity, and position. It's very important. Okay, in your packet, flip to the next page if you would. Okay, we have a group review. I want you to get together with a, let's see, a group of 3 I think we could do. We have 8, 9, 10, well, oh, you're going? Okay, so a group of 3. And start going through the review packet. Okay, there's a couple things on there. Oh, Jake, before you go, let me give you this. This is your homework. It's charting from chapter 5. Okay. All right, get together with a group of 3, so you have multiple brains, which will be perfect. We'll have 3 groups of 3. And go through the packet. You don't have to start right there. You can, start on a different part. Pick the section you want to work on, because whatever you don't get done, you'll need to keep working on until the test, which is on Tuesday. All right. Where are groups of 3? Let's see groups of 2. Group of 3. You 3 ladies? And then Amisha or Ariel, you gonna come over here? Okay.